Okay, thank you guys for coming. Today I'm going to present how we at Stereocolor can deliver VFX shots with tight turnarounds as just a two-person artist team, and how we utilize a generalist mindset and automate the boring stuff to be able to focus on what really matters to deliver great pictures. And we also show how Houdini helps us in that regard. So a little bit about us. We're founded in 2020. We're an agency/CG production studio. We're a four-person team, but only two artists, and we're spread out in Sweden and Dubai. We work fully remotely, and we started out as a Maya studio, but in 2022, we switched over to Houdini as our main tool. We consider ourselves generalists and like to sort of go through the whole CG pipeline. And that has led us down the path of sort of building our own streamlined pipeline and automated processes. As a two-person team, sometimes we act as a studio and sometimes as freelancers or sometimes somewhere in between, where we take over full sequences for bigger production studios and deliver CG for them to finalize in comp. So I'm going to start by showing our show reel for showing some projects that we've been doing the past couple of years in those types of roles. So today I've got to take you through the process of 3 projects that we delivered last year. And each had unique challenges that forced us to think outside the box and to be able to deliver on time at the quality that our clients expected of us. So first off is Formula E, Progress is Unstoppable. This is a collaboration with Rascal Post. They did all the comp and relied on us to deliver CG of the car, environment, and plane. It's a 60-second teaser for that year's Formula E competition. And we did the asset build for car, driver, plane, environment. There is a mix of full CG and visual effects shots. For shot production, we did tracking, animation, light. We're 2 artists, and we managed to deliver 28 shots in 6 weeks. So that's roughly 4.5 shots per week starting from day 1. You can split these shots into 3 categories. You have the traditional visual effects plate, and they actually filmed this in South Africa with a crazy rig with an actual car on top of it. But the job was, of course, to match move that so that we could have a CG, perfect rendered CG digidouble to do rig removal and also add some extra camera movements and spinning the wheels and such to sell that it's flying through the air. Then we also had stunt footage shot with a GoPro of skydivers, where we would match and animate in a CG car. to fit that plate. And finally, we had full CG shots where everything is rendered. Here's a look at what we delivered. So we have the car asset build, which is pretty basic stuff. And then to the right, you see the plate we received versus the final render that we'll send to Rascal to finalize the comp. And a quick overview sort of the workflow. I think most of you are used to working like this, but we received the CAD file from client. That had to be fixed up, adding UVs, fixing inconsistencies with what we saw on the plate inside of Maya. And then we did the texturing inside of Substance Painter, and finally pushed that to Houdini to do the look dev. And for shot production, we received the plates with track and match move, the car and camera. And then as animation, we spun the wheels, added the seatbelts when the driver was out. And then some of these shots were sort of locked off cameras, and we wanted to have some more dynamics. So we're sort of animating the camera, but it's still having the right proportions between the camera and the car that we see in the plate, but to add some more dynamism. So we're tilting down the camera, for example, to sell that it's falling towards the earth. And finally, we bring animation and camera into Houdini, where we had a shot template and pushed through rendering. And each stage here generates a lot of data, and especially if you're just two guys and they have 28 shots to deliver, it can be quite a lot to keep in your head or look around in spreadsheets. So if we were to receive a new track, then that has to be pushed for animation, all of that, and same with model, that will have to go through all the steps. Luckily, just before we received this job, we had developed our first version of our pipeline. So this was a good pilot project. So our internal tool is called Scope. It's a lightweight Python-based pipeline. It's built to just make life easier and set scene defaults in our Houdini scenes. It automates things like file structure, versioning, and publishing. And we can set settings on a task basis where we can set the environment, resolution, OCIO settings, what plugins and HAs to load in, and sort of have a continuous development during production to push new stuff to our artists. And then we built a universal web frontend, since I can't spend all my time developing, since I'm also delivering shots. I figured that if I make a web frontend, we can reuse that in Houdini and all the other DCCs. So this is a quick look at how we would set up this project. So on the left, you have the show with assets and all the shots, and each shot can have subtasks. In the middle, we assign data, like a spreadsheet. And then on the right, you sort of see the result of Scope taking care of making all the folders, as we work, saving everything in the correct place. So we sort of never have to think about or introduce any human errors when doing this manually. It's also possible for us to save any arbitrary data to a task, and that allows for some interesting workflows. Here you see Scope inside of Houdini as a PyQt window that's just a web browser. And from here we can sort of trigger Python scripts that will initiate sort of pipelines functions and create HJs and such. Inside of Houdini, Scope is mostly doing I/O kind of stuff, so we can open and save files, publish and import publishes, and see all the versioning of publishes and such. Here's a look at how we can use arbitrary data to sort of create procedural workflows. So here I have created two variables called driver and environment. And those are controlling switch nodes that plug in different render layers into our farm node. So then we can, on sort of a sequence level, set all the data in Scope. And if we just open the scene, or in this case, I already had it open, so I had to apply the settings. But now sort of all the switch nodes has changed over to render without the driver and without the environment. And those override nodes that you saw, another nice thing with doing this another nice workflow thing in Houdini is that we can fix something, and then that fix will turn into an HDA. So we created these override nodes, which can take any input and then create checkboxes where you can sort of override individual parameters. And that's very useful for something like render settings that has a lot of different things to configure. But you want all your render layers to have a shared common base, and then we can just override what the forced object and forced light each layer will have. And then we just pipe it into the farm node to render everything in one go. And this, we didn't do any sequence lighting or multi-shot specifically in this shot, but you can see sort of how you could make a base setup, and then for each shot sort of have one override node for the beauty, for example. And you can stack these, so you can have how many overrides you want. And here's a look at the light template for Fonny. And what's of note here, I would say, is our publish nodes. You see we have some turquoise nodes that are selected that's looking for anim camera and anim geo. And those are set to be task relative. So they will sort of know which task they belong to and pick the right version from there. While our car asset is an absolute path. So it's always picking the car, but it's picking up the animation and camera depending on what shot we're in. So I'm going to show you how quickly we can go from this. So Salah would set up this, Salah, my partner, would set up this light template while I was working on the animations. So here he's finished shot 26, and I just pushed the anim geo camera for shot 27. He's able to go into scope, change the task he's working in. Then in the status page, it warns you that we have the wrong frame range. So he has to update the scene. And then if we have a look at our publishes, everything is up to the latest version, except for the relative publishes. So we just update those. And then we end up with the first version of shot 27 that's ready to render. And then we can just iterate on this from here. And then we can save the scene, and it's going to save in the right folder with the right name and everything. And this is something that we developed during the project. So towards the end, I did a cheeky little test where I went through and in a lunch break was able to sort of make these rubber toy versions of the whole show and push them all to the farm and have them by the end of the day. So that sort of shows just by adding I/O layers on top of Houdini and then utilizing some of the procedure workflows, how we can sort of get that iteration time down to very short times for such a small team. And yeah, that's how we managed to deliver a show like this. And we were able to spend time where it most mattered, like fixing the look dev and the materials, tweaking the lights, adding extra passes that the Rascal needed. And I think in the end we got something that we're very proud of, and think Rascal did a great job finalizing the comp. Next project. This one is a small one. It's a commercial for poker site Betsson that feature a lot of poker chaos. This was in collaboration with Naive, which is a Swedish full-service production company. They needed help with 4 shots that needed a little bit more of a sim animation. And since they had their own 3D artists, we were very collaborative and shared asset back and forth during production. So we worked on 4 shots. Here we go. It's not showing. There we go. So these are the 4 shots that we worked on. As you can see, there's a lot of moving stuff going on. And this shot required, instead of being hand animated, we relied on simulations. And I'm going to walk you through how we sort of animated this. So we start out with tracking the shot and setting up the geometry for the room. We would lay out everything with the curves to sort of get a nice flow and nice layout. Then we would add in hand animated objects, and these would sort of be reactive to whatever was happening in the plate. So you had people dodging, flying stuff, and so forth. And the sim setup is pretty basic. It's just a rigid body solver, mainly driven by a pop curve force. And I think to get a good looking natural result, you usually should stay away from trying to force control it too much. You just need to find the correct magic settings and then just let it play out and do its thing. That way I think you get the best natural looking result. And to achieve this, it was my first time using PDG. So here's an example of what we got from setting wedges for follow scale, suction scale, and random start positions. So now we sort of could get an overview of the full spectrum of how those values, because they are sort of playing against each other. So you want to find a good median settings for both of them. So you see the top row, it's sort of all floating way too much. The forces, both forces are too weak at the bottom. They're both too strong, so we end up with fast moving objects. I think we ended up picking somewhere in the middle. While researching PDG, I found that this is a very powerful tool set, and I would like to use it more often. I found that there's a bit of a hurdle to set up the initial sort of network. So then I came up with why not sort of make up my own workflow so I can get up and running with PDG quicker. So I think this is a good example of how you could, with small Python scripts, find your own workflows that suits you in order to sort of speed up your work. So here I've added settings for adding wedges by right-clicking on parameters. So I'm adding wedges, and then I can add geometry outputs. And if I now go to my task area, I see that there's a quick PDG network created by the script. It already has a flipbook and a geometry output, and all the wedges that I added. So this is sort of the hurdle I was talking about, sort of setting all this up, jumping between context and sort of linking everything up, giving it names. It's very powerful that you have that fine-grained control, but I wanted to sort of be able to do this before I went on lunch or before I leave for the day. And then you don't want to be stuck sort of for too long. You just want to be able to select a few parameters and hit render, basically. So I set up some values, and then it's default as a single frame, so I'm going to set a frame range. And this sort of cuts down the time quite a lot to where we can use it more spontaneously. And then you can get results like this very quickly. So going back to our bets on shot, now we sort of picked the sim that we liked. We added an additional sim for assets falling on the ground. And lastly, we put in some smoke and debris simulations for objects hitting the pillars. And here it is with our lighting. This is just a slant comp, so it's missing some roto. But that's close to the final result. And speaking of lighting, let me show you how we lit these shots. So this is the track geo where we projected an HDRI as a base. And then we project the plate with some fading to the sides, so we don't get a hard cutoff. So now we're starting to see some nice reflection in the objects. And as you see in this plate, we have a lot of light sort of flashing in different colors. And we found a sort of neat trick to deal with those. Instead of sort of animating light for hand, we could utilize COPs. So here we have a little setup for foreground light and background light, where we place a grid, and then we project the plate on top of that grid, and then we extract that as a texture through COPs. And then we can reference that COP node directly on our lights. So we see this white part on this chart. It sort of changes color as the scene is changing. Now if we take a look at the pillar in the background, that has another color that it's picking up from the plate. And if we just apply those colors to our light, we get something that matches pretty good to what we see in the plate. So here's the final lighting with gray shaders, and then finally with materials. And since I mentioned we worked with HIVE, so they were sharing assets, and we got to a point where we had a approved lighting, but then we got updated assets where they would update the UVs. And sort of we started out with one set of diamond, and in the end we had 5 different shapes. And what's nice in Houdini is that we can just extract those transforms for that one diamond and randomize it to be 5 different ones. And also for the assets, we had playing cards that went from having one common UV to 5 models where the UV were shifting around. So we were able to randomize that as well, on top of the animation we already did. And that's how we sort of figure out these shots. And one takeaway here is sort of how just working and solving problems that you have in one project can lead to a tool like the quick PDG that I showed you. So that's something that we have with us and can use day by day by now. And sort of, it's just these tools are sort of compounding and making us more and more efficient. And finally, we have Asta, Pop the Buble. This was a Christmas commercial, and it's another project we did with Rascal. We provided CG renders for the set extension. We're creating the solution of an endless Christmas warehouse. This was a big layout challenge because we have a lot of like products and shelves and Christmas details. So let me show you a little breakdown we did to illustrate the size of the CG space. There we go. So a quick overview of how we sort of approach this scattering. We have published models, and then sort of we do layout in multiple steps, layout and scattering multiple steps. So we build up populated shelves, we make stacks of boxes, we make Christmas scenes with the Christmas trees, and then we take those layouts and bring them into sort of big scene layout where we can randomize even further. And then we only export the points, and the points have the asset name and the transform with them. And then we can bring in the model separately into the light scene and do our instance in the light scene with a copy to points up. And this saves a lot of data storage and makes it so that we can update the models separately from the layout. So I'm just going to show you a few examples how we sort of achieve this semi-random look. So for the shelf, we define the scatter surfaces, extruded up to define volumes. For each volume, we made sure that we could fit 2 assets and sort of put them in a row. And then in front, we sort of fit a set of boxes, and then every box picked another box. And then if that box was small enough to be put on top, we put it on top. And then by sort of playing around with the seed in a for loop, we could generate a lot of different assets. So I think in the end, we outputted 50 shelves like this. For these box stacks that we sort of see in between the shelves, we're sort of imagining this a 3D Tetris effect, which is a pretty hard thing to do. So we came up with a solution where we sort of have 3 sizes of base volumes that can all have the same height. And then we sort of stack them up until we reach our preferred height. And then we take each of these boxes and sort of manually we do the Tetris 3D sort of layout. At the start, we imagined this would be a much bigger noticeable effect where we would go all the way up to the ceiling, but then we reduced it down. So we only see the 2 top layers. So we got away with just having 2 variants for each box. And for the trees, we just add a bit of boxes to the ground. And you see some of these boxes are also the ones that we use for the shelves and the box stacks. So it's sort of reusing assets in different layout stages. And then if we go to the sort of big scene, here we have geometry from the track. So these are the shelves that matches the on-set shelves. And while I was working on sort of the populating shelf, Salle was able to work wider and sort of think of the whole space. So he would come up with this, and then when I had the shelves ready, he would just add a seed to what shelves he's placing, and we could pick the one that we liked the most. And from there, we could randomly pick a few empty spaces to put the boxes, a few empty random corners to put the trees. And by now, I think you get the gist of it. We sort of have a similar setup for the garlands and all the sort of lighting and fire lights that go crisscross across the screen. And I want to highlight this, maybe a lot to read, but how we did this was we were able to, our pipeline can publish Houdini nodes, and those nodes can themselves have published references. So we would have a nested set of references, which meant that on a shot-per-shot basis, we could lock different versions of boxes and maybe change out a few assets depending on client feedback without having to go back to the previous steps. And since everything is copy to point with packed geometries, we can set the visibility options for everything and get the great viewport performance. There you see some hand-placed objects for this specific shot. And everything is sort of snappy to work with, and we can play back the shot in real time. And that's how we managed to solve the scattering challenge of ASTA. So I think hopefully what I've shown today is how we can, with the small additions, such as I/O handling with scope and sort of variables that can be used to set up full sequences procedurally. Showed how we can sort of speed up workflows for small teams, and how while we're working, we can take workflows and turn those into HDAs or small Python scripts that we can reuse for all future projects. And that's what I'd like to call the Houdini hustle. Thank you. All right. Do we have any questions?
Questions? Yeah.
Hi. Great talk. I was wondering, like, when you said you were switching, like, for example, in your scope, and you were switching around if you're doing lights and you're doing an animation. Are you guys always working like in one scene and just change your context in the scene as yourself? You do the lighting and the anim in the same Houdini file, basically, and just switch the context? Or how do you handle that as a two-man team?
Yeah. So it depends on the job. I think most of the time we set up a sort of development shot, and then we would sort of populate the rest of the show by doing the context switching. And then if we're going back to a shot that we sort of have done some work, we usually, what we can do is we can change the context within the same Houdini scene and then reload it. So we basically get back to the last saved version. So that's how we do that.
Thank you. Really cool. It's fun to see this type of pipelines.
Yeah.
Yeah.
Any other questions? Yeah.
Hi.
Hi.
Sorry. I was wondering, you said you were working remotely,
yes,
and you also have a farm. Do you work on the cloud, or do you have like an office and everybody connects to that place? Or how do you handle the logistics? Is everything on a single server? Do you work on your home computers and synchronize, or how do you handle this?
So it's very simple. We work on our home computers. For syncing projects, we're relying on Dropbox, works fine. And then for farm, we use services for that. So what we've been using in these shows is the Chaos Cloud farm.
And yeah, the second question was, what render engine are you using?
Yeah, Primarily V-Ray, but we're sort of switching between depending on the job.
Thank you.
Hi, great talk, very impressive. So do I understand right that scope is something you developed during the Formula E project in the 6 weeks, or because it seems quite comprehensive?
No, it was developed before that, and we just released the first working version. What was developed was the task relative publishes and imports, because we saw that that's something that could really help us out. So we sort of we had a base that we kept developing on during the project.
So how long did it take to get it to this state? Because it's very impressive.
I think I spent a summer on it, so maybe 2 months, something like that.
Wow, great.
Anyone else? Awesome presentation. Thank you very much.
Thank you.